Atmospheric pressure. In this lesson, we will learn about air pressure. Atmospheric pressure is the pressure exerted by the atmosphere of Earth. The envelope of gases surrounding the Earth or any other planet is called atmosphere. It extends up to 800 kilometers above the Earth. An air pressure of 9.8 Newton unit square centimeter is exerted on our body. But we do not collapse because there is air pressure present within us. The force within us balances the force pushing us from outside. The pressure inside our body is roughly the same as the pressure outside, so there is no net pressure on us. Atmospheric pressure can be measured using a barometer. It is mainly used in meteorology. The bar is a metric unit of pressure. It is exactly equal to 1 lakh Pascal. It is approximately equal to the atmospheric pressure on Earth at sea level. Now, let us perform some experiments on air pressure. Take two identical plastic bottles, A and B. Fill cold water in bottle A and hot water in bottle B. Put the lids on the bottles and keep them undisturbed for some time. Next, remove the bottle caps and pour the water down the drain. Put back the lids of the bottles. Next, place both the bottles inside the refrigerator for 5 minutes. What do you observe? Nothing happens to bottle A, but bottle B gets crushed. The air inside bottle B expands due to the hot water. When the bottle is placed inside the refrigerator, the sudden cooling creates a partial vacuum. The extremely low pressure of the partial vacuum inside the forces the higher pressure of the air outside the can to crush it. This experiment thus proves that air has pressure. To perform this experiment, you will require 2 straws, a glass soda bottle, some water, and some clay. Fill half the soda bottle with water. Put 2 straws in the bottle so that the ends are under the surface of the water. Seal the mouth of the bottle with clay to prevent air from entering inside the bottle. Next, try to sip some water through one straw with the second one left open. Now again try to sip water, but this time close the second straw by keeping a finger pressed over it. In the first case, when you sip water, the atmospheric pressure becomes lower. It pushes the surface of the water. Since pressure is transmitted equally in all directions, it will push the water up the straw and into the mouth. In the second case, when you try to sip water with the second straw covered, it does not allow the atmosphere to push down on the surface of the water. Thus, water does not move up into the straw. This experiment proves that air has pressure. For this experiment, you will require 2 different colored straws, a glass of water, and a pin. First, using a yellow straw, drink water from the glass. Next, with the help of a pin, make 1 or 2 holes in the blue straw. Try sipping water from the glass using this straw. When you sip water using the yellow straw, the air pressure inside the straw is reduced. As the air pressure outside the straw is higher, it pushes down on the water, and in the process, forces some of the liquid up the straw. But the blue straw with the holes allows an endless supply of air to come in. Therefore, the air pressure is never reduced and the liquid never travels up the straw. This experiment also proves that air has pressure. Hand pump is used for bringing underground water to the surface of the earth. It uses human power to move fluids or air from one place to another. Most hand pumps have a piston that moves back and forth inside a two-valve cylinder. The suction pumps have a cylinder situated above ground level or near the surface. When the piston is pulled up, it creates a low pressure or suction in the cylinder. Because atmospheric pressure is fairly low, the pressure difference between the inside and the outside of the cylinder causes the water to push up the surface. A siphon is a tube that transfers a liquid from a higher level over a barrier and then down to a lower level, with the flow maintained by gravity and atmospheric pressure. To understand how a siphon works, let us perform an experiment. Take two straws and push them one side the other. Tape them. Fill a glass with water. Next, bend the straws at one of the flexes. Place the shorter end of the bend into the water. Suck the straw to fill it with water and quickly bend the longer end down below the level of the water. When you allow the filled straw to drop below the level of the water, it begins to flow from the glass. However, if you don't hold the straw down lower than the surface of the water in the straw will simply fall back into the glass. When you drop the straw below the water level in the glass, the water in the straw is pulled down by gravity. This creates a vacuum which helps in drawing water from the glass through the straw. The flow of water can be stopped by raising the outside end of the tube above the level of water in the glass. A number of devices that involve the flow of liquids through tubes work on this principle. It consists of an inverted U-shaped tube which causes a liquid to flow upwards, caused due to the pull of gravity, and then discharging it at a level lower than the surface of the reservoir. A liquid always flows from a high pressure area to a low pressure. The liquid in the container is at high pressure. It thus flows up into the tube, which is an area of low pressure. As the liquid flows outside the tube, the pressure at the top of the tube again becomes less. Thus, the process continues. Atmospheric pressure also helps a liquid to move into a syringe when its plunger is withdrawn. Take a plastic syringe without the needle. Next, pull on the plunger to fill the syringe with air. Put your finger over the end to seal the opening. Put your thumb on the plunger and squeeze. You will see that as you apply pressure, air is squeezed into a smaller space. The harder you squeeze, the smaller the gas gets. The plastic on the end of the plunger makes an airtight seal with the plastic tube. So when the plunger is pulled back, a vacuum is created inside the tube. If blood or medicine is present on the outside of the needle, it gets pulled into the empty space by the vacuum. When you press the plunger back down, it just pushes the liquid back out through the hole at the end of the needle. Some other applications of air pressure are inflating tires, playing musical wind instruments, drinking through straws, filling ink in a fountain pen, flushing toilets, fixing a rubber sucker, and operating a vacuum cleaner. Excess of air can be harmful in certain cases. We know that the air pressure in a balloon keeps it inflated, but excessive air causes it to burst. Similarly, excess of air in the tires of a cycle or vehicles can cause them to burst. Under no circumstances should a tire be inflated beyond the maximum rating, since it may reduce contact with the road